1. This is from Unit 1, and maybe we've forgotten a little bit how to do this, or maybe we just really get scared when we see a radical. But if you want to find the components of a vector, you have to take, you can take, some of you recognize this, some of you haven't. You can just take the terminal point. This could be something you would put on a note card. Terminal minus the initial point, and you get your components of the vector. You will get x and you will get y, your horizontal and your vertical component. So this is exactly what we can do on this problem. We can take our terminal point. It is okay that it is a radical. We don't need to be scared of that. 1 minus the square root of 2. And we could subtract off our initial point, our starting point. Now there is no horizontal shift. We go from 2 to 2. So our horizontal component is 0. Our horizontal component is 0. You might have needed a calculator for this, or maybe you just simplified your like terms. 1 minus the square root of 2 minus 3 is going to simplify to negative 2. 1 minus 3 is negative 2 minus the square root of 2. If you put that in your calculator, it's about negative 3.41. If you got your vertical shift to be negative 3.41, you're doing just fine. So let's look at what this is on a graph. 2, 3 is my starting point, and then my terminal point is 2, 1 minus 2. That is straight down. Sorry, it looks like my calibration's off a little bit. Straight down, no horizontal shift, it's just a vertical shift, down about negative 3.4. So these are our components. Now if you want to find the direction, I'm going to skip to the direction, I'll get back to the magnitude. If you want to find the direction of this vector, you want to reposition it so it's at the origin. This one worked out nicely because it's going straight down. What is the angle from standard position of this vector? It's
270 degrees.
It's 270 degrees. So our direction from standard position is 270 degrees. It lines up with the negative x-axis. So I go 90, 180, 270. Magnitude. This is a formula you have to memorize. The magnitude, similar to Pythagorean theorem, is the square root of your horizontal component plus your vertical component. Well, we found our horizontal and our vertical component. What's nice is one of our components is 0. So this actually makes the calculations very easy. 0 squared is just 0 plus this, plus the square of the vertical component. What happens when I take the square root of a square? It stays the same. Those are called inverse operations. So because this is 0, I don't have to worry about it. And when I square root a square, I end up with, now everything would become positive, right? Because when I square a negative number, it becomes positive. And this is going to be, if you put it in decimal form, our magnitude is about 3.41. The size of this vector is 3.41. Now, yes, the vector is going in the negative direction, but its size is not negative. Remember, magnitude deals with distance. Yes?
Why is it 2 minus the square root of 3?
That comes from over here. If I look how far I travel from 3 down to 1 minus square root of 2, when I subtract these, that's a negative 2 minus the square root of 2. Which again is about 3.41. It's going down 3.41. This vector is going in the negative direction.